has 5 different types of attractions: the Ferris wheel, the swings, the merry-go-round, bowling, and the cake. The last 2 are considered games, while the first 3 are considered rides. Okay? Before leaving the fair, Jane wants to do 2 activities, 2 more things. First thing we want to do is list the things she can do. Now, in order to do this, I'm going to simplify by doing abbreviating. What I'm going to do is I'm going to things S, the merry-go-round M, bowling B, and the cakewalk C. And please do feel free to abbreviate as long as you make it clear what your abbreviations stand for. Now let's see what Jane could do. She could do the Ferris wheel and the swings, the Ferris wheel and the merry-go-round, Ferris wheel and bowling, and Ferris wheel and the cakewalk. Now let's look what else she could do. We'll start with the swings. She could do the swing and the Ferris wheel. We already got that one listed. The swings and the merry-go-round, swings and bowling, and swings and cakewalk. Then she could do the merry-go-round and bowling, merry-go-round and cakewalk, or lastly, bowling and cakewalk. Notice for this purposes we considered something like merry-go-round and cakewalk the same as cakewalk and merry-go-round. It doesn't matter what order she completes them in, she's still going to end up doing the same 2 activities, so order was not important. We just want to see all the possible things she could combine together. Let's count up the total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 different combinations of events. This will be helpful when we go to look at probability. What is the probability that Jane will ride the swings and play the cakewalk? Well, if you notice, swings and cakewalk is only one of the options. One of the options out of 10. Turning this into a decimal, 1 divided by 10, will give you a 0.10 probability. What is the probability that Jane will ride the merry-go-round? So we need to go and find all of the things with merry-go-round. We'll color those green. And we want to be careful we don't forget anything. Remember, even if she rides the merry-go-round second, she's still riding the merry-go-round. So I have 4 things out of 10 total, or a 0.4 probability. What's the probability she will do 2 games? Now remember, the cakewalk and bowling were considered the games. What's the probability she does 2 of them? Well, let's find any possibilities that are bowling and cakewalk, because those are the only 2 games. Well, I think I only see one way for her to do 2 games. So that will give us a 1 in 10 probability, or a 0.1. What's the probability she does not play any games? That's really the same thing as saying what's the probability that she does only rides. So let's color that tealish. Only rides. Well, Ferris wheel and swings are only rides. Ferris wheel and merry-go-rounds are only rides. I'll try and color that blue a little bit bigger. Ferris wheel and bowling. Nope, there's a game there. Ferris wheel and cakewalk, game. Swings and merry-go-round. Okay, that's okay. Only games, or only rides. Swings and bowling and swings and cakewalk are out because they have a game. Merry-go-round and bowling, merry-go-round and cakewalk, they're out. And bowling and cakewalk all involve a game, giving us a probability of 3 out of 10. So it's important to use your list to help you get your probabilities. Remember to add up your total number of possible combinations as your bottom number. And for the top number, we always look to see how many of those things on the list meet the certain criteria.